Network Components and Devices, Part 2. Well, as I'm doing this nugget, Star Wars Revenge of the Sith just came out, and you know, it's rare that you have a sequel that's a lot better than some of the originals, and I think that was the case in this one too. Well, I hope in this little sequel to Network Components and Devices that you'll find this sequel a little bit better than the original. So let's get into it. Let's get into Part 2. Okay, in this nugget, we're going to look at 6 main categories of network components and devices. We'll start out with the ever-popular router device, then a device that's commonly confused with the router. Actually, it's what a router used to be called, a gateway. We'll talk about gateways. We'll look at transceivers. We'll also talk about ISDN adapters, which you may need to use in older implementations, the ever-popular, ever-invasive modem, and then finally, a couple of examples of security appliances. Sound good? All right, let's dive in. You know, I just got through watching on HBO the movie The Postman, or The Postman. I don't know how you pronounce that, with Kevin Costner. And boy, it really reminded me of how important it is for the movement of mail and messages for civilization. If you've seen that movie, things can really break down fast. But that really reminds me of why routers are so important, because being able to move information and route it from site to site, from location to location, from network to network is critical to your network infrastructure. So what we're going to look at here first in this Part 2 really is understanding the functionality and the different types of routers out there. By definition, a router is a computer system. When I say system, typically I mean a hardware device, but a router could be also software. You have routing software on your operating system, whether you're using Linux or Windows XP or Windows 2000. You've got some routing software on there as well. Now, this router computer system is there to transfer data generally between networks that are using the same protocol. In our case, that protocol is going to be an IP protocol, an internet protocol. So the router is going to connect at least 2 networks. These will be commonly 2 local area networks connected together, or it could be 2 wide area networks, a couple of metropolitan area networks, or typically a local area network connecting to its ISP or its service provider's network. It does this typically by reading address information on all of the data packets. And this will be destination, and we're talking about IP here, so destination IP address information. Now we're going to talk more about IP addressing later on in this series, so we'll wait on that to discuss IP addressing. It looks at the addressing information in those packets and it forwards them on to the proper end network and ultimately the proper host. Routers are used in small to medium-sized businesses and up to complex networks like enterprise-wide networks and, of course, the global internet. Routing and forwarding processes occur at layer 3 of the OSI model. We've got a nugget coming up that's dedicated to the OSI model, but you need to know that routers operate at layer 3. Now let's say that all these routers here in this particular diagram are part of a really large enterprise network. These routers are going to determine the proper way to send data packets based on their current knowledge of the network state. So routers are going to create or maintain within memory a table of the available routes, and they're going to use this information to figure out the best route for a particular given data packet. Realize, if a packet's going from this router across wide area networking to, let's say, a router over here, it may break up that message into several data packets. It may not follow the same path to get to that particular destination network. It may actually be rerouted based on different states of the network. Maybe you've got congestion in certain areas. Maybe you've got a particular router that's down. It may route packets along different paths to ultimately get to the destination. Now, it generally uses a routing protocol to gain information about the network. This information can be statically or manually inputted into the particular device using a command line interface, or you can use dynamic protocols that we'll look at later on, like RIP version 3, open shortest path first. These are proper and very widely used protocols. Routers also use a protocol called BGP, Border Gateway Protocol, between domains on the internet. So we use these routing protocols to dynamically acquire information about the state of our network, the topology of our network, and all these routing protocols use different mathematical algorithms to choose the best route based on several different criteria, but these criteria are known as metrics or parameters. Metrics or parameters. Oh, and actually make a note here. I just remembered that really the most recent version of RIP, Routing Information Protocol, is RIP version 2. So let's go ahead and keep that in mind. RIP version 2 is the most recent version. There's not a RIP version 3 out right now. So ultimately, routers are similar to bridges, but they provide a lot of additional functionality, like the ability to filter messages and forward them on to different places, different network locations, based on different metrics or parameters or different criteria. This is why the Internet uses routers like this fleet of Cisco 12,000 series routers to forward packets from one destination network and host to another. Now the cool thing is you don't have to have a router to see a routing table or a route table. For example, I'm using Microsoft Windows XP. All I have to do is go and open up a command prompt window here and get to the C prompt, and I can type in the command route, and then I want to print out my routing table, and when I do, I'm going to see the routing table for this particular host. So you can have a workstation or a PC that has routing software serving as a router to move packets, especially if your workstation or your server has more than one network interface card in it. It's very common for servers like a Linux server or a Windows 2000 or a Windows 2003 server to be multi-homed, which means it has multiple network interface cards, and just serve as a router. You can save money not having to spend all that particular extra coin to get a standalone router device. Now, of course, standalone router devices have a lot more functionality, a lot more commands that allow you to do a lot more things, especially when it comes to things like security. But we often use servers, Linux servers, Windows servers, for simple routers to put at the perimeter of our network to run firewall products, proxy services, things like that. And you can see I've got several active routes in my table with destination IP addresses, masking information. We'll explain this to you upcoming nugget. The gateway is simply the next hop, the router that's the next hop away to route the packet to this destination network. And what is the interface? What is the IP address of the interface that I'm going to go outbound to route this packet to the network destination? So here's a route table I got by just simply typing route print on my Windows XP machine. Let's go take a look at a real router interface. What I'm looking at is the command line interface, or accessing the administrative configuration aspect of this hardware device. This is a Cisco 3660 router. And what you see right now is just a basic prompt, a command line interface prompt. Realize that the operating system that's used by Cisco, that's used by other manufacturers, Nortel, 3Com, Hewlett-Packard, they're all really Unix based. So if you have any experience with Unix or Linux, this should be very familiar to you. You're just going to type in some commands. Even if you've used Microsoft DOS, you should be familiar with the command line interface, basically issuing commands and different variables and parameters to administer, configure, and set a particular hardware device. Now if I go to this particular device, I'm going to type in the command, I want to show the version. It's going to show me the version of this hardware device. And if I scroll up here, by the way, you can access these devices in a variety of methods. I could connect a cable from a laptop or a workstation directly into the console port on the hardware device and get access to the command line interface, or I could use a program like Telnet or Secure Shell, a more secure version, to get terminal emulation into this particular device. Right now I'm actually using Telnet to connect remotely to this particular Cisco router. Now when I do a show version command on this hardware device, it shows me that the operating system I'm using is the Cisco Internetwork Operating System, or Cisco iOS. It shows me the iOS version. It's a 3600 software, and you've got some versioning information. This is just software versioning. Your major revision number is 12. A minor revision number is 2. And you have sub-levels after that to kind of explain what are some of the extra add-ons I might have in this operating system. And then it goes down and just has basically some legal information, and then it shows, for example, how long this particular router has been up and what type of system image file we're using. This is kind of like the image file that you'd be using, let's say, for Windows 2000. You have a particular file that represents that operating system image, and this just shows the binary file here. It's really long. There's a bunch of information that's included in this that shows the actual image file that's stored in a certain kind of memory called flash memory. And then, of course, it just goes on to give you more information about the fact that this contains cryptographic features, and I probably couldn't take this router and just, sell it on eBay and send it over to some country, some foreign country, without breaking some laws. If I hit the tab key, it goes down and shows me more information as well. And it gives you more information about the types of interface device you have. This is an enterprise edition of this particular router. It's got a couple of Ethernet interfaces, a couple of fast Ethernet interfaces, a couple of serial interfaces. It's also got an ISDN BRI interface and one ATM network interface, and it shows you the kind of memory it has and the kind of processor and other information. And then to configure this particular router, and configuring pretty much any network device, you generally have to get into a configuration mode. Well, in this particular device, I have to type in config or configuration or configure, and then I'm going to configure the terminal. So I'm going to configure the terminal on this device, and it puts me into what's called a configuration mode. If I type in a question mark, it's kind of like help, and it shows you all the commands that I can now issue, and all of these commands will have a subcommand and subparameters that go with them, but all the things I can configure on this router. And if I hit the space bar here, it just moves me through all the different commands. And again, this is like the Unix operating system, but it's got commands specifically for this router network device. By hitting the space bar, I just kind of scroll through all the many commands. You can see IP, there's the global IP configuration commands that you're familiar with. And if I hit the space bar, it continues to go down and give me many commands. Okay, there you go. Now, again, I'm accessing this router through what's called a command line interface, but I can actually configure this router through a web-based interface if I want to. All of your different major vendors will allow you to access a network device, whether it be a router or a switch or a hub, or let's say it's a more specialized security device, let's say like a firewall appliance, or maybe it's a VPN concentrator security device. You have the ability to access these devices through a web-based interface as well. Now, I realize one of the downsides to web is it uses by default a protocol HTTP, which isn't a secure protocol. So you've got that threat maybe of a man in the middle being able to intercept commands and access information that you send from either the workstation or laptop you're using to connect to this device. kind of being in the middle there, intercepting this in clear text. So there is a security vulnerability by using web-based access. And once you try to access devices over the internet with web-based access, as opposed to just internally in your organization, well, it starts to compound the security threats. Next, we're going to talk about a gateway device. Here's the logical symbol for a gateway, and it's kind of really a funny thing to describe. Realistically, the term router is now used in lieu of the original term that was used for gateway. Typically, a gateway was something that gave access inbound or outbound between networks. And we saw earlier in that routing table where it had that column at the top there that was called gateway. It's an old convention, okay? Gateways used to represent points of entrance and exit from communication networks, but currently a gateway is really a communications device, a special kind of device or application that passes data between networks that may have similar functions but different implementations. For example, maybe a wireless network to a physical local area network or an ISP. Wireless devices that we see, wireless routers, are commonly called wireless gateways. You can see one here. Here's one from Linksys. We've got wireless gateways. We've also got these other rack-mountable gateway devices. Now, gateways function at all different layers of the OSI model, which we'll talk about later, but by definition, a router can be considered a layer 3 gateway, where a mail gateway, MAIL, which could be a server, a mail gateway is a layer 7 or an application layer gateway, like a gateway between email systems, allowing users on different email systems to exchange messages. That's a layer 7 or application layer gateway. A gateway can also use protocol translators. It can do impedance matching. It can do rate conversions, fault isolation. It can be signal translation, anything necessary to provide interoperability between disparate systems. For example, gateways nowadays will commonly provide links between video conferencing. I'll put VC here, video conferencing system. For example, a gateway to an H320 ISDN video conferencing system that a corporation might use. So bottom line is gateways provide communications and applications processing interfaces between networks with similar functions but different implementations. As a matter of fact, things like AOL and Prodigy, among many others, have been considered gateways to the internet. Another device to be aware of is a transceiver or a media converter, as it's often called. Now, a transceiver stands for transmitter receiver, so it's a device that is really full duplex, transmission and reception. Also known as a media converter or adapter. It's typically used on routers for different cable connections, like an AUI to RJ45 transceiver. As you can see here, you've got an AUI jack that basically converts over here to an RJ45 jack. This is a very common transceiver that you would see on a router. Let me give you an example of my particular rack, and I'll show you how I use my transceivers. Here you can see the back of one of my routers where I have one of those Unicom transceivers here that is basically converting this AUI DB15 port to a RJ45 Ethernet jack. So some of your older routers will still use these AUI type of ports. Generally, the newer routers, however, are using all RJ45 jacks, or you'll see with the gigabit networking moving up to what's called a GBIC. These transceivers that we're looking at right here are GBIC transceivers. This is a standard commonly used with gigabit, Ethernet, and fiber channel. GBIC stands for Gigabit Interface Converter, GBIC. It converts the light stream from a fiber channel or an optical cable into the electronic signals that are being used for your network interface card. It allows 1 gigabit Ethernet port to support a full range of physical media, from copper media all the way up to 100 kilometer single mode fiber. I'll just put SM mode fiber. So remember the term, along with transceivers, remember the term GBIC that's used with gigabit networking for fiber channel and optical cable conversion. Now realize that ISDN, which stands for Integrated Services Digital Network, has been around for over 30 years, and it's a digital method of moving voice and data, very popular, even though you're seeing it being replaced lately with things like frame relay and ATM and other high-speed broadband solutions like cable and satellite, as well as DSL. But ISDN is still around, and older implementations need an adapter to combine with the CSU DSU unit that adapters use. So you may run into implementations where you have to have adapters on both ends of the transmission. Generally on the server side, you use the CSU DSU. You probably don't need to have an ISDN adapter installed. Newer implementations always have the adapter built in. For example, here's a Cisco card right here in this diagram. You can see this particular Cisco card just gets popped right into a Cisco router or multi-layer switch, and it has the ISDN adapter built into it. But if you're using devices that are not ISDN aware, like telephones and modems and other types of devices, older devices, you may need a separate ISDN adapter to go along with that particular telecommunications device so that it can support ISDN transmissions. That's where ISDN adapters come in, and you don't see those very often anymore in newer hardware implementations. Modems. The modem. These have been around for such a long time. I'm pretty confident that you know what a modem is. You have some experience with it. Remember, modem really is short for modulator demodulator. Okay, it's a device that lets your PC or your workstation talk with other computers by using a dial-up connection to the internet through some type of service provider. A modem is going to modulate outgoing digital signals. It's going to modulate those from a computer to analog signals that give you transmission over your conventional telephone lines. It then demodulates the incoming signal, okay, the incoming analog signals into a digital signal for your computer. Now, modems come in two general categories. You've got internal modems, like this one right here that uses a PCI bus architecture, an internal modem, or it may be an external modem, like this Linksys cable modem. You might have a cable modem or a DSL modem. You may even have a wireless modem that's external to your PC or workstation. Typical modems for example, an internal modem like this will operate at 14.4 kilobits per second, all the way up to 56 kilobits per second. If you use a 14K modem, it's going to basically translate into approximately 1,600 bytes per second. Now, when you get into DSL and cable modems, you're going to get much higher bandwidths than that, depending upon your provider and the agreement you have with that particular provider. I use Cox Cable. I have a Cox Cable modem. I get rates anywhere between 128K to 256K, depending on the time of day. So modems are modulators, demodulators, and they come in a wide variety of flavors. All right, good job. By the way, this is the official logical symbol for a modem. Now, the last category of devices are firewall appliances and VPN appliances, and we're going to talk about these devices in greater detail later on in the security elements of this Network Plus series, but I'm going to go ahead and define what a firewall appliance is right now. Here's the logical symbol, by the way, for a firewall, and here's the logical symbol for a VPN concentrator device. Now, a firewall by definition is a hardware device or a software application that functions in a network environment to prevent some communications that are explicitly forbidden by a corporate security policy. Now, firewalls can be implemented in both hardware versions, like these dedicated firewall appliances here, or they can be software running on a server, or generally they're a combination of both. Now, a firewall is analogous to the function of a firewall in a building construction, a windowless wall to prevent fire from spreading from room to room, or those firewalls that are kind of like wide roads that are built through forests to prevent forest fires from spreading or jumping across. So think of it in that application to provide security for your organization. The basic task here is to control traffic between different types of security zones. What you generally do with a firewall is you have 2 or 3 interfaces, maybe more. One interface that is connected to your internal part of your organization, which needs to be the most secure interface, and the interface that goes to the public. You may also have other interfaces that go to other security zones, like a bastion host, for example, maybe a demilitarized zone. But generally the interfaces going to your ISP or your public is the one that needs to have the most security applied to it, the most filtering going on. You'll have zones of trust. Internet zone right here where you basically don't trust anybody, and maybe you have an internal network where you have a high degree of trust on these devices. Your goal here is to control the connectivity and the packet flow between these different zones. And as your packets flow through this device, in memory, information is stored here, binary information, and you can look at those packets, you can investigate those, and you can find out which particular packets meet your particular policy. Again, the goal here is to prevent unauthorized internet users and hackers from accessing your private networks. This also includes intranets, your web-based corporate internet, and extranets between you and strategic partners or vendors or customers. Again, the firewall examines all the messages that enter inbound and exit outbound from your network. Now, what we're looking at here are some dedicated firewall products, as well as from Cisco, some dedicated VPN concentrators that are used to create virtual private networks, using a fleet of protocols to encrypt and decrypt traffic between 2 terminated endpoints. The concentrators allow you to have a bunch of remote access users or a bunch of remote access businesses, let's say they're small branch offices or extranet partners, that can create encrypted, decrypted traffic specifically between you and these remote end users out there or remote branch offices. So you generally will use in a large enterprise organization or a medium-sized business a combination of firewall appliances and VPN appliances to provide a total security policy to control inbound and outbound traffic. Again, you want to make sure that you have your private network is protected from the public network, the unsecure networks of the internet, and we use these appliances. Now, you don't have to use dedicated firewall appliances or VPN appliances. This can also be software solutions that are running on servers, or it could actually be integrated into the routers that are sitting at the perimeter of your network. The operating system on Cisco routers, for example, allows you to have firewall and VPN capabilities, as well as intrusion detection services as well, built into the operating system of the router or the multi-layer switch device. But as I mentioned, we're talking about different types of network devices here, so don't forget we've got firewall and VPN appliances. Now, to access these and to manage these, we can use a command line interface that's Unix-based, or we could use a web interface. Let's take a look at an example of a couple of those. As you can see, as we're on the VPN 3000 concentrator series from Cisco, that sometimes you manage and administer and configure these network devices using a menu system as opposed to a standard command line interface. Now, when we looked at the router, the 3660 router, and the 3550 switch, we had that typical Cisco iOS command line interface. But what you see here on this VPN concentrator, and you'll also see this on older switches, is you have more of a menu-driven system. So if I want to configure this, I would type in 1 to get to the configuration area. If I want to configure an interface, I would type in 1. Shows me my IP addresses. If I wanted to change an IP address, let's say for the inside interface of this VPN concentrator that connects to maybe an internal server or an internal workstation that's using to manage this device, I could just type in 1 and go and set that private interface. I'll choose 1 to do a static IP. So I can say this device, I'm going to 3 enable it using a static IP address. And it shows the current address is 10.16.1.3. Maybe I'll change mine to a Class C 192.168.100.3 and hit enter. Now by default it wants to give it a subnet mask of 24 bits, the default for a Class C, 255.255.255.0. If that's okay with me, I'll just hit enter, and I've configured an interface on a VPN concentrator. Now, this is the command line interface. It's menu driven on a network device. But let's go take a look at this particular device from, let's say, a web-based interface and see how we would manage this with a graphical user interface using HTTP and web. As you can see, I'm accessing that same VPN 3000 concentrator using this web-based interface. And again, whether it's Cisco or Hewlett-Packard or Nortel or 3Com or many of the other fantastic vendors out there that supply security appliances and security products, all of them are going to have some type of web-based interface. I just happen to be a Cisco guy, so I'm using this particular interface to get access to this concentrator. And again, this could be a firewall product, a firewall appliance that I'm accessing. I could even access that router or a switch using a graphical management interface. Now I'm going to log in here as admin and type in the password, and then let's go take a look at this, and you see you've got basically this web-based interface, and it gives you a menu. Now all of these different areas we're seeing here of configuration, for administration, and for monitoring, all of these things can be done through the Unix-based graphical interface. And again, some people who are those kind of command line junkies, well, they'd rather work in that command line interface. I call it the dark place. They'd rather work in the dark place. You may want to work in a web-based interface. And honestly, if you're going to manage multiple network devices, if you're put in a position as a network administrator where you have to manage multiple routers, multiple switches, multiple hubs, multiple end-user workstations and laptops, even multiple VPN concentrators or firewall appliances, you're going to want to use a graphical interface that kind of gives you enterprise configuration over many devices. And all of the vendors, and there's lots of third-party solutions as well, companies like Tivoli, for example, or Computer Associates, Network Associates, that provide these third-party enterprise management stations and operating systems and add-ons to your present solution. So you can see here I can go and I can configure all the features of this device, interfaces, the system-wide parameters, managing users, groups, and users who access this device, policies, creating tunnels, point-to-point tunneling protocol tunnels, layer 2 tunneling protocol tunnels, IPsec tunnels. I can also create secure shell or secure sockets layering and what Cisco has called Web VPN. So I can do all of this through a web-based interface. And again, you can see I'm using the HTTP protocol here to access this particular device. I could have gone, if I wanted to, back to the beginning and actually used HTTPS to get a secure connection to this VPN device. Not a bad idea. All right, great job. Well, in part 2 of Network Components and Devices, we covered 6 main knowledge areas. We looked at routers, we looked at gateways, we looked at transceivers, we also talked about ISDN adapters, modems, and then finally, 2 different types of security appliances, firewall appliances, and VPN appliances. Also along the way, we got a look at the command line interface, and finally, a web-based interface for managing a VPN concentrator. You know, I really hope this CBT Nugget's been informative for you. I want to thank you so much for viewing. Hey, we'll see you next time.